This is going to show you how to use Desmos to create a confidence interval for population standard deviation. The only problem is I had to write basically this app, because it's not something that's got a preset tool for already designed in Desmos. So you have to put in the size of the sample, and later on down here it finds the degrees of freedom, and it turns on a chi-square distribution for that size of the sample, and thus degrees of freedom. Then you put the given standard deviation. So this is how you find a confidence interval for population standard deviation when you're given the summary statistics. So when you know the standard deviation of the sample, of course you would need to know the size of the sample. Then you change this value right here. You slide this to find to set the confidence level. It'll automatically find the significance level alpha and store it into A. And I've sent the area inside the bounds to be the confidence value of C here, and then that gives you the chi-squared left and chi-squared right values, which you have to click on here and then download them by clicking this button. So you can see that they go there, and then you would just push L equals to set it to that value. And then they do the same thing for the R value, for the chi-squared right value. Download it and then set it as the R value. So I already did that, but you can see I have those values down here below. So I'll just turn that off, but showed you how you do that. Then I turned a point on the x-axis for the chi-squared left value here and the chi-squared right value here. And there's a little place to turn on the label. And that just helps you to understand that if the chi-squared test value is in between those values, you do not reject the null hypothesis as we move forward in using confidence intervals to do a hypothesis test. But this the upper and lower limits that are used for the confidence interval are I've just written the formula that we used when we did this by hand. Okay, so that's the left value, the lower value for the confidence interval, and this is the upper value, which I've labeled right below them with text. There's exclamation points because Desmos doesn't understand what that's all about when you just write text. So if you want to do this for when, instead of having a summary, having the summary statistics where you know the size of the sample and the standard deviation, you can just drop the data set into this box right here. And I called it H because it was standing for some data set that we went over in class where H was the first letter of it. I'm trying to remember what it was offhand, but whatever data set you have, you just have to paste it in there, and it will automatically, with this formula right here, N equals the length, it'll find the size of the sample. It's kind of a strange tool, but that's what you use to find the length of a list, which measures the number of items in the list. So it knows there's 25 data values here. Again, you would move this button to slide for the confidence level. So this example that we went over in class was for a 98% confidence interval, and it gives the lower and upper limits again, but here is where it found the degrees of freedom, and I asked it to find the standard deviation of that list H that's obviously needed in order to be able to find the critical values. And here again is where you would download both the chi-squared left and chi-squared right values, which I stored into L and R and labeled them again on the x-axis. And then I just decided to refer to the variance with S squared. So if you remember the formula for finding the lower and upper limits for a confidence interval, it's the square root of the degrees of freedom multiplied by the variance divided by the chi-squared right value, and the upper limit for the confidence interval is the degrees of freedom times the variance divided chi-squared left. And this is just the downloading of those L and R values from here and here, where you've been able to turn on those points on the number line for a visual. So as we move into hypothesis testing, we'll find that when a value is inside this shaded region, when a chi-squared test value lies between these values, we will not reject the null hypothesis, and when it's in the tail, we will. But for the time being, this is just how you would use Desmos to find the lower and upper limits for the confidence interval. All right, hope that helps.